Hello everyone. I hope your exam preparation is going well. We will be solving AS Physics 9702, Paper 2, Variant 1 of October-November 2024. Before moving on to the first question, I just want to let you know the sequence in which I will upload the entire paper. I'll first create the playlist of this entire paper, and in the playlist, you will find 7 different videos. Each video will have a different question. Like, for example, if I talk about this paper has 7 questions. That means there will be 7 videos. Each question will have a separate video of its own. So, without any further delay, let's move on to the first part. The question 1, part A says define density. This is a very easy question. No need to waste time over here. Define density. Density is equals to mass per unit volume. Mass per unit volume. The part B says figure 1.1 shows a cuboidal glass block. This is a cuboidal glass block. Let's see what the question demands with this block. A student measures the mass m of the block and the side lengths x, y, and z. The measurements are shown in table 1.1. The table, as you can see over here, has two portions. On the left hand side, the quantities are given, and on the right hand side, the measurements are given. But each measurement has its absolute uncertainty. Since absolute uncertainty is given over here, it means that in the later part of the question, we will have to deal with the uncertainties as well. So, without delay, let's proceed to the first part. Determine the density of the glass. The density is equals to mass upon volume. Mass is 0.243, and for volume, what we have to do, we are given three sides. Since volume is equals to length into breadth into height, mass is 0.243, and the sides are, there are three sides, but we cannot simply write straight away write the sides over here. As you can see in the table, the sides are given in centimeters. So first what we have to do, we have to convert these values in meter. As you know, 1 meter is equals to 100 centimeter. We will divide each value, since we know that when we convert from smaller unit to bigger unit, we have to divide the value by the conversion rate, conversion value. So we will have to divide each value by 100. 5.41 will be 0.0541 into 0.1109 into 0.0162. So simply put this into your calculator and you will get answer 2500 kg per meter cube. Moving on to the next part, calculate the percentage uncertainty in the density. As I already told you that the absolute uncertainties are given over here. That means in the later part, there will be a separate section for uncertainty as well. So the question is demanding the percentage uncertainty of in the density. So for the percentage uncertainty, what we have to do, we have to first calculate the fractional uncertainty of density. What is the formula for fractional uncertainty? Uncertainty divided by actual volume, actual value. Absolute uncertainty divided by actual value. So the formula for density is rho is equals to mass upon volume or mass upon length into breadth into height. So fractional uncertainty will be, since we are dealing with multiplication and division over here, So the fractional uncertainties in the fractional uncertainty, the values will add up with each other. Fractional uncertainty of mass plus fractional uncertainty of first length is x plus fractional uncertainty of y plus fractional uncertainty of z. I hope this is clear enough. The fractional uncertainty or the absolute uncertainty of mass was given 0.001. The actual value was 0.243 plus I'm simply putting the values over here as given in the table 0.01. The length was 5.41. As you can see over here, I'm not converting the values in meters since we are finding the fractional uncertainty over here. When we are dealing with fractions, there is no need to convert the values. Why is that so? If I will divide this by 100, I have to divide that by in absolute uncertainties as well. So if I divide both the values by 100, then in division, since the denominator and the numerator are same, these both divisions will be cancelled out and we will get the same value. So no need to waste our time in this. The certainty of y upon actual value of y 11.09 plus 0.01, that is the absolute uncertainty of z upon actual value of z, that is 1.62. So by this we will get the fractional uncertainty of density. Simply put this in calculator, you will get 0.013. That is the fractional uncertainty of density. But the question is demanding percentage uncertainty. So not a big deal for percentage uncertainty. Just multiply the value by 100. You will get 1.3%. That's your final answer. I hope this section is clear. Now let's move on to the next part, that is part C. The part C says the true value of the density of the glass is different from the answer in B1 because of a systematic error in the measurement. The systematic error is the keyword in this question. State one possible cause of the systematic error. So when systematic errors are possible, or the systematic error occurs when there is a zero error during calibration. Since the two measuring devices we are using over here. The first one is the vernier caliper to calculate the vernier caliper, meter rule to calculate the depth and length of the cuboid, and the beam balance to calculate the mass. So there could be a zero error during the calculation, during the measurement. I hope the first question is clear. If you have any questions, you can comment down below. Thank you.